Hello everyone, this is Sai Arananshu and my teammate Tejaswini. And this video is a quick presentation about our project for pattern recognition. So I'll just share the screen for the presentations and yeah. A quick one sentence summary of what we did for this project is we developed a music genre classification system using CNN and public data sets where once we upload audio file, it would automatically detect what type of genre it is. More about the how we did it and a live demonstration later. So and basic responsibility division. So um, so I know you have built the CNN models and LSTM model to perform the basic genre classification and also have deal with MFCC extraction for the audio features. And then finally, handling all the FFmpeg related issues on the local machine while setting it up. And over to Tejaswini to discuss about hard part and continue with the presentation.
Hi, I'm Tejaswini. My responsibility was data validation and system development by cleaning and verifying audio data. I have designed a Flask frontend with initiating an email alert system and maintaining project documentation and milestones. Next, we'll see introduction. Uh, so basically, our music genre classification is a well known problem in pattern recognition and multimedia analysis. With the growth of streaming platforms, there is a large amount of unstructured audio data available. So, classifying this music manually is subjective and does not scale well. Uh, Different listeners may even disagree on the genre of the same song. So, this music genre classification is very important and a very challenging task. So, this is where it comes in, like to differentiate the genres. Uh, Next, we'll be seeing aside. Next, we'll be seeing dataset loading and initial analysis. In this analysis, we will be evaluating audio signals and different genres. So the several challenges are audio signals are high dimensional and time varying, and also different genres often share similar characteristics, but some genres overlap significantly. So our task is to design a system that can extract meaningful features and learn discriminative patterns from audio data. And then next we'll be seeing the correlation analysis and heat map. Here you can see the correlation heat map in the image that we have generated from our data set. These are the selected, like all features columns containing mean and computed correlation matrix between selected features and applied a triangular masking to avoid redundancy, used a diverging color map so that it would be visually clarity for everyone. So heat map saved for documentation and analysis is here. The image is present here. And next we'll be seeing the tempo BPM analysis across genres. So basically, a tempo is a key musical feature that varies significantly between genres. To study this, we have generated a box plot, and we created comparing BPM values for each genre label. The visualization highlights differences in central tempo tendencies, and some genres exhibit consistently higher tempos while others are slower. This analysis helps connect musical intuition with numeric feature patterns. Next, we'll be seeing feature scaling and PCA visualization. So here is the visualization of the two genre labels where the different colors are given for a different things, like classical is for a different genre and country is for different color. So here you can see the genre differentiation. Next will the future features are normalized using min-max scaler, and then scaling ensures fair contribution of all use. PCA applied to reduce data to two components, and PCA output combined with genre labels, and scatterplot generated to visualize clustering. Next, next slide. Next slide would be taken care. I'll hand over it to the Arnab.
Yeah, so quickly discussing about like what is like MFCC basically and how we are deriving from the raw audio. MFCC, as it says, like melt spectrum spectral coefficients, several coefficients, not the spectral, which means it's an inverted of inversion of a spectral image, which then is overlapped between different well values. And these values, when extracted from an audio clip, generates the defining factor of each and every particular genre. So that's our key feature that we are targeting for the genre classification. And those features are then fed to a CNN model. So the CNN model, which again will be shown during the demonstration, is a very basic CNN model, which again uses the MFCC, which we generated in the previous steps, to classify the incoming genre. And then we have different higher order features too, which again, like discussed earlier, are like tempo of the beat. Um, that's again like useful for the classification. Then finally, to stabilize the training values and like improve the convergence speed, we have used like batch normalization, and dropout has been added to like prevent the overfitting that usually happens. So we got an accuracy of 78 to 82% depending on the seed, which is not significantly high, but we plan to use keep the accuracy low on purpose. Um, because we don't want an overfitting problem on our data sets for the model. And how did we evaluate and test the models? So we used a test split, and we have stored the test data set, which is completely unseen, away from the CNN model. And then the finally trained model is tested on the test set, which gave us an accuracy of around 80%. And for each, and also we have a few additional completely unseen values or unseen files, which we collected from in general like Google. And those were again fed to the model, and the accuracy was pretty good. So as you can see in the screenshots, we have 77% prediction of it's a pop audio, where the actual classification was also pop. Um, and then results, we plotted across the results in like four different plots. So first is confusion matrix, which is pretty known, where we try to identify how many false positive or false negatives, and then true positives and true negatives are there. So as it's pretty evident that except for the jazz and classical, the confusion matrix values are pretty in line to our accuracy score, which is about around 70% or above that. Um, and those two, the classical and the jazz, we believe is only because of very similar MFCC values to other classes. And this can easily be avoided if we train further on, but we didn't want to have an overfitting model for other classes. So we had to early stop it. And then comes the ROC curve, where it shows the it confirms whether the model predictions and actually are good and not just correct by chance. So usually the high area under the curve in ROC result indicate that MFCC features are actually good for journal discrimination, and you can see like the area is really high and it's way above the dotted line, which is baseline. Then comes the segment-wise predicted class. One second, there's a disturbance. So then comes the segment-wise predictor class where um, at a given particular flow, if, Teju, can you mute the mic? Mm, on this Teju side. Yeah, and then comes the segment-wise predictor class, where this plot shows us how the segment, I mean, how the audio is predicted at each particular interval in a given clip. So as it progresses, there it identifies the MFCC values midway, and then predicts it as one of the classes that it can possibly be. And you can see like the predictions are pretty solid, and it happens accurately at any given point instead of randomly diverging for each given segment value. And finally, whether the outputs are reliable or not, the dotted line is the perfect calibration where it usually happens when it's overfitted. Luckily, it didn't happen in our case, where the models estimate um, uh, is like we check whether it's aligning or not. And it clearly does in as it progresses in later stages for the accuracy. But yeah, it is kind of not aligning in the starting stages. So finally, to conclude our project basically was to create a music genre classification and then attach to a software using like Flask, which will be again shown later on. And the genre classification, I think, achieved a greater accuracy at the end, which came around 80%, and the results are pretty balanced. So in most of the cases, when we tested out with unseen data, which is completely out of the data set, the predictions were in line and accurate. So moving on to the demonstration. So a quick demonstration of the entire code that we have is yeah, sorry for the pause. There was a network issue. So coming to the IPNB, we have the same. It's just a playground for us where we have the plots generation scripts and the dataset scripts. So all these plots are the ones that were included in the presentation too. And then comes about the model that I was discussing in the presentation, which was a CNN. And so the scripts that we have over here are the dataset loading and processing of the entire data sets for the MFCC generation and then a model creation. So for the model, this is the architecture that we chose, where we have the max pooling layers and batch normalization to avoid the overfitting, and then the conv layers for the CNN to work. So these are the total parameters that we have. And then finally, we got an accuracy of 78% where we stopped the epochs to prevent the overfitting. And this is how our curves look. Moving on to the Flask application, Tejaswini, you can take it.
So, this is our Flask application. This is a basic Flask code, and we have generated the website from the IP, whatever IPYNB we have trained the model that we have generated into a created a website. Uh, so this would be our Flask code, and we'll next go to the website.
Yeah, so the website looks something like this, where we
And
have the entire routes prefixed over here. And once you upload a file, let us say you can upload the text external files which are relevant to the ones we trained on. That's a sample from the file, and when you click on predict, it will take you to the prediction page / prediction, which shows the exact prediction. And we even have other pages that we attach just for the theme going on for the website. So in the home page, we have all the basic directions to use the software. And project page, we have a basic description of how the project works and what we did in this project. And then in about page, we have about us and why we built this project. And then finally in contact, we have our names and a contact email address. So that's our entire project. And more a more detailed demo video will be attached too. So this is more about our presentation and why we are doing this project and what were our results. A detailed demo video will be followed soon. Thank you.
Thank you.